Okay, okay, so maybe we can begin, and in the meanwhile, like the people will join. So thank you very much for joining this call. Thank you everyone for being here. This is like the fifth of the AgriHackathon webinars back. So we make AgriHackathon last year, and we are following up the all with the expert and with like different contribution to create a knowledge base about
Domenico, your voice is not coming.
Can you hear me? Can you hear me? Hello? Can you hear me?
Your voice is not coming.
Hello? Can you hear me?
We can hear you.
Okay, okay, perfect. Hi, Moran, welcome. So I was saying this is the fifth webinar after AgriHackathon, and we are following up actually the innovation that we did into the AgriHackathon last year to prepare also to the next year. Today with us we have a very important guest, that's Luisa Fracassini. Luisa Fracassini works for ST Microelectronics, and she's coordinator of the OpusLab. And with we will see today with her the potential and the possibility of smart agriculture, and also we can say agriculture 4.0. Also on the direction of having a sustainable agriculture. So Luisa will show us a lot of innovation that is going on the technology side for agriculture, and that can be really helping the activities of farmers and the practitioner of climate smart agriculture. So I'm glad that there are with us several friends. There is Nyoka Divine, that is AD of the Global Climate Smart Agriculture. There is, sorry, the Global Climate Smart Agriculture Youth Network, Emma Turdumbre, and other colleagues that after the presentation of Luisa, I asked to interact. So Luisa, I will give the floor to you.
Your voice is not coming.
Hello, hello.
Your voice is not coming.
Hello, can you hear me? Maybe check your audio. Check your audio, Dr. Dumbre. Okay, I will give the floor to Luisa to introduce herself and to show her presentation. So Luisa, please, to you.
Okay. Good afternoon to every one of you. I'm Luisa Fracassini. I work in ST Microelectronics since a lot of years, and I'm responsible of sustainability and open innovation there. And so today we will speak of smart agriculture for a sustainable world. This is the name of my presentation. And mind, it's very important. These two words, smart and sustainable, must always go together. There will be no future if with the no technology, but there will be again no future if the development will not be sustainable. Sustainable and sustainability are rather overused word. Perché non va avanti? Oh mamma, non va più avanti. Perché non va più avanti?
Try to share again the screen.
No, but it was working before. I tried it.
No worries, no worries. Just try to okay.
Sustainable development, a very overused word. But let's go to a definition. That is the first definition. It's simple, but is very exhaustive. Is the definition given in a Bronton Commission at the United Nations in 1987, when this discussion of sustainable development arose for the first time. The definition is meet the needs of the present without compromising the ability of future generations to meet their own needs. This is very simple, but is very important, very pregnant. So we are working for a smart, sustainable world. But why we need a smart, sustainable world? Why can we go on with this traditional world? Because there is some boundary condition, some mega trends that we cannot avoid and that force us to change. For example, the demographic dynamics, the increase of population and the concentration of the population in a big city, big metropolis, and again, from the demographic point of view, the aging of population. Fortunately, the age of the people increase, but these give needs, create needs that must be satisfied. The second trend is the problem of the resources. Finite oil and gas reserves. Water is becoming the blue is very important, both for the problem of desertification, but even for the again for the problem of big cities that need pure water in a large area with millions of persons. And then again the problem of waste and disposal. The third trend is the climate change, that the CO2 emission and the consequent demand for clean energy. These require a great change, require a revolution. It's not possible to go on with a continuous improvement, small little improvement. We have to make a revolution, a great change. It is called the fourth industrial revolution. Is the revolution of IoT, Internet of Things, and AI. Internet of Things is a new paradigm that based on this, that all the objects, diverse, different objects, personal and other objects, are all connected to the internet, can be connected to the internet, and become nodes of a big network that allow a potentiation of service and a superior capability over the single one. And this is addressing also fields that before was never touched by electronics, by 4.0, and between these disciplines that was never touched by electronic technologies, there is also the farm and food field, so the smart agriculture. This is rather news. It's only a few years that electronics is penetrating the farm and food field. Smart farming. Why smart farming? Which are the reasons for smart farming? First of all, smart farming aims to provide a sustainable agriculture to improve the livelihood of farmers. This is the first important reason, to give to farmers best life condition. Then have crops of a higher quality and higher volumes, because the population is growing and they need to have food, but quality food. Enhance nutritional value and safety of food. Food must be very safe and must contribute to the health of the people, and have less impact, agriculture, minor impact on the environment. To become nodes of this IoT network can help to have many important consequences. For example, save water, reduce the amount of chemicals by sensing the parameters and acting in consequence. Optimize the harvest and the seeding and all the operation using smart machines, and monitor also the crops, the livestock, the animals. And the big importance also of collecting data, to have the possibility to collect data and analyzing this, have a lot of information to increase the quality and the yield in the fields. Let's go first of all to see what happens in fields and vines in the fields. The trend is to put control units, distributed control units, many distributed control units connected between them in a neural network, and addressing cloud, where artificial intelligence algorithms allow to extract info, for example, info on the yield, on the water, if it's irrigated or not, the fertilization level, which are the condition of the ground, the health of crops, and then on the base of this info, drive action, consequent action. For example, when to give water, how much water, when and how much deliver fungicides, insecticides, and herbicides, and fertilizer. And then alert in case of pest attacks or disease, typical crop disease. And even suggest which is the better moment for harvesting. So collect data and give information, give counsel and suggestion in consequence. All controllable in remote on the smartphone. This is an example of one of these unity of control. Is a device that allow the analysis of the health of crops and the status of soil nutrients. It's composed by a soil probe inside the earth, inside the ground, and an air probe. You can, with this device, you can measure a lot of parameters: nutrient concentration, nitrate, potassium, phosphorus, ammonia, methane, nitrous oxide, pH, temperature, humidity, and in such a way to dose your action on the field and reduce cost. I don't enter the technical details of which are the technical part of the system, because it's not the place here to go into details. But what we can see here is the dimension. You can see the dimensions are very small, are very concentrated. There is the air station and then the probe that enter in the ground. This is the solution powered with batteries. That is an actual solution that is popular now, but as a negative point, that is that you have to change the battery. Battery can last, let's say, 3 years, but then you have to change them. And if you think that there are in a field, there will be hundreds of these devices, it's not so an easy question to change the battery. What we are going now, and this is a special thing in which my company is working, is the wireless and batteryless solution. This will be the same system, but with a technology that allow not to have battery, because the energy will be very small, the required energy will be very small, and will be delivered by our solution of harvesting, energy harvesting, that are very interesting and that are not invasive. And for example, this is one a part of the standard solar panel that is a no technology, but that is become less invasive because we will move to PET film base instead of a silicon base, and so there will be more light, more disposable, ecological. But this is another particular solution that is to be able of collect the energy that bacteria in the ground are naturally generating. These bacteria are present in any type of soil, and as long as the plant is live, they elaborate the dead roots material with the photosynthesis and generates electricity. It's a very small electricity, but since the new systems that we are developing require very few power, it can become a solution. We are already running trials of this particular interesting solution. For example, this is another application of technology in the fields that, again, on which we are working for to be batteryless, and is a smart trap to catch insects, parasitic insects, and with the artificial intelligence, recognize them and understand if are insects that are not dangerous, or if they can become a pest for the field. This is another work that we are developing in our labs, and is a pest control. It's an idea that we don't know if it will work, but we are looking for this. This is a parasite of vines that communicate the male with the female. They communicate with the noise of their wings. They scratch the wings and produce a vibration, a signal, a sound signals, vibrational signals. Our idea is to understand the protocol that they use to communicate, because they use a particular protocol to communicate, understand this language that they use to enter in communication, and then substitute a machine reproducing the same message, the same message of the female insect to attract the male and trap it. So it's a particular idea. But the control, this smart control apply not only in the field, but on all the food supply chain. So from the field, for example, for wine, from the field to the bottle. So starting from what we have seen before in the field, there will also a control in all the steps of the vinification, of the process to arrive to wine, with a monitor of many different parameters like turbidity, like density, color, many parameters to certify, control first of all, and certify all the steps of the process. And it's called traceability from field to table. And now it's starting also for oil. Up to now, it is reserved to the very expensive wines and oil. But with the decreasing of cost, it will become accessible for all the type of wine to control, to have the control of the good and quality of the field. This is already applied. This company of Champagne, Rank and Pomery, has already applied this way. They put all the control units, and this is growing. They are collecting a lot of parameters. They are controlling disease, pest prediction. They can anticipate the production, the quantity and the quality of their production, even to plan their deliveries, the cost, the price, and so on, and have the full supply chain traceability. These are the parameters. Also, packing is the packing of the food is undergoing a big change with the increase of technology. For example, these are the smart interactive package. They adjust the atmosphere and are specific to prolong the life of the food inside the package, and to maintain the quality parameter and the nutritional parameter. This is brand new because this type of package is realized with a polylactic acid, so with a very safe material, and is realized with a 3D printer. Very particular, realized with the 3D printer. this is, for example, a possibility of this package. They can, from the gases that the fruit becoming juicy, become, we say mature, but it's not a word in English, become going toward the readiness. The color of the dot on the package change. So when it's red, it's crisp. When it's orange, it's firm. When it's yellow, it's juicy. And if you go to the supermarket or your fridge, you can understand which is the grade of ripeness of the product. And then there are other solutions. These are intelligent solutions in which there is a real circuit printed on the plastic of the package that can memorize all the trend of all the story of the package. For example, you see there below 8 degrees, it means that this envelope of salad has never undergoes overgo the 8 degrees. So it's been refrigerated all the time and has not had accident during his life. The other solution that you see on the right is a way to monitor on a tag the freshness of the eggs. Let's pass to the greenhouses. So from the field, we pass to cultivation in greenhouses. Now there are coming more and more frequent the high-tech greenhouse. This is an example of a greenhouse in Italy. Very big. It is completely automatic. All is controlled by technically, not by human intervention. Irrigation and humidity, fully managed by software. It reads the condition of the humidity and adjusts the irrigation. The cultivation is done in hydroponics crops, rock wool, that allow to put many more plants for square meter. They recover the rainwater, saving 30% of water, and even the water, wastewater that come out from the ground after the use is not absorbed by the plants, is recovered and give another 20% of saving. There's no chemical usage because it's all controlled and for example, for the parasite, for the insects, parasitic insects, they use beneficial insects. So if they introduce beneficial insect that eat the dangerous insect and keep the pests under control. They recover the heat from biogas plants with the waste of the cultivation. They feed biogas central and they use biogas. Recover the CO2 that is emitted during the night, and so avoid to introduce in the atmosphere other CO2. And also the light, the technology reach also the lamps. These are sea-led lamps that are very technological. They are able to emit the light. No, okay, first of all, we can see which is the result. The result is that the harvest is no more seasonal. They have no more one collection per year, but they continue to produce even in the winter period. The yield is much bigger and is much higher. The characteristic, the nutraceutical means the good benefic substances in the food are very improved. Vitamins, antioxidants, they reduce the malformation, so the fruits are perfect, are good, and resistant to pathologies, and have also many more flowers and in consequence fruits. How they work? First of all, they give the right quantity of light that is needed from the different plants, but also the type. Every plant, every type of vegetable has a different spectrum of light in which it works the best. So for the tomato, the light must be in a range, for potatoes in another range, for grape in another again. And these lamps are able to emit the light in the better frequency to give the maximum results on the specific plant. Direction, they are able to orientate the direction of emission to give them more illumination to all the plant with the homogeneity and with the no shadow area. This gives a lot of results on yield. The other thing that is changing are the machines, the Agri automated machines that help a lot the life of the farmers and the results. This is an example, a typical example is the rubber collection. Rubber collection is something that is very, very heavy for the poor farmer that have to collect this, because they must do this from the 2 a.m. to 5 a.m. They have to do all manually and cannot work during the rain. And until a few months ago, there were no possibility of robotic solution for the interference from the big power lines for wireless communication. The solution is now a robot that uses a particular technology, LoRa wireless technologies, that is immune to power line interference. And so the heavy activity is all done with the robot. Quindi better condition for the workers, information of what is full, and reduce the loss of rubber, optimal yield, information on the quantity, and estimation of the cost for the market. But all the factory can be automated. All the steps of the factory, sowing, harvesting, hoeing, weeding, fertilizing, everything can be automatized with machines and improved. This, what you see here is a robotic farm, fully robotic farm, realized in Australia by the university students. Australia has very big fields, enormous fields. They fly with the airplane from one farm to the other. And they realize this robot that can, here you see, they monitor fruit by fruit the state of ripeness and decide when to collect it. They are solar powered, so with less impact on the ambient. And here, for example, this is recognizing and taking away the bad herbs, bad plants, and can even for the parasitic, they can understand where there is the pest, where there is the insects, and give the poisonous substances only in that area. Is very. They can work 24 hours, 7 days. And this is also developing new jobs, new type of jobs, because they have to realize the robot, do the maintenance of the robots, do the programming. So it's giving rise to new professions. This is another example of an intelligent machine. This is I don't know the name in English. We call trattore, but I don't know which is the name in English. Sorry, of this equipment. And tractor. Okay. And this is able to understand the tire is a smart tire, and is able to understand the type of soil on which it's working. and control its pressure, its strongness on the floor on the base of it. So it's not pressing too much a soft floor soil, and this give a very higher yield because the soil is not too much compressed, and then is able also to understand the difference of planarity. You know that many workers on the tractors die because it goes which is the word, goes with a wheel up and turn on itself. And these smart tires allow to be stable also in with pendants with unequal soil, and save the life of the driver. Also the kettle can become smart. This is a controlled kettle. They use this feature of cows that have 3 different stomachs. 2 of these stomachs are not in direct contact for this. If you eat something, it goes out in a couple of days. There is the other 2 stomachs that are not connected directly. So they prepare some pills, electronic pills containing a lot of sensors. They give it to the cow. They are not dangerous at all. And with all these sensors in their stomach, the worker can understand if the cow has drank, if the temperature, if it moves, or if it's passive and not in activity, if it's in heat, if it has problem of digestion, if the cow has eaten good food and enough food. So the health of the cow is much better, and also the life of the farmer that can control everything of this from his smartphone is better the same. Also the early announce of the arriving of a calf bird. Smart food. Also, the food can be can have advantages of smart technologies. For example, this is a very interesting thing. This is a chip, a special chip that recognizes DNA. You can, if you have to recognize a DNA, you put a sequence or a filament of DNA of what you want to recognize inside the chip, and when you put the sample to be controlled, it can understand if there is compatibility, and that means that you have the match is confirmed. This can help to understand the food. For example, for the religion that don't eat pork, for example, they can control that what they are eating is not pork. But even if they are saying you that you are eating deer and it's not deer but dog, so it can allow to understand food detection. They can understand food origins. So this is a Parmesan. There is a lot of counterfeiting of DOC food, and this can control that you are really buying a original food and not a bad copy. Pathogens can detect the presence of pathogens in the food, and can also control the freshness of the food. Okay, this is all the explanation, but it's too technical. Let's skip it. Another example, these are bees. Bees are very important. Bees are fundamental because they perform the pollination. And but besides this, they can be also a powerful indicator of the health of the environment around them, and also of the impact that on this environment have the presence of men and of the manufacturers and all the change that men produce around them. We are running a project with 5 stakeholders working together to realize a smart hive utilizing very, very advanced techniques. We are the heart, the core of this team. We have an inventor of us that is inventing this smart hive. We are working with the University of Trento with a professor. This is the professor that is studying the bacteria, the energy from bacteria. There is an entomologist from another Italian university. And then we are working also with Apicoltura Urbana, that is an enterprise that install and take care of hives in the city, in the companies, in the parks and school. We are working all together to realize a very technological hive that can do a lot of measures that, first of all, allow to understand if the bees are in health, if there are some danger inside. But we are also going to use this information on the health of the hive, of the bees, as an indicator of the health of the surrounding environment. If the bees are in health, the environment, external environment is healthier. But we are trying to demonstrate it with the numbers. So these are a lot of parameters that we can check with our sensors. Another possibility is that is the one to address the pathologies that are causing the death of the bees. For example, this is a parasitic Acarus. Varroa acarus. It is this is this eclopa. Varroa is a parasitic Acarus that go on the bees, enter the body of the bees and cause the death of the bees. We are studying a system to kill the eggs of the Varroa acarus, Varroa mite, without giving any disadvantage for the bees. And I want to close the presentation with this phrase from Einstein that say, if the bees disappeared off the surface of the globe, the man would have only 4 years of life left. No more bees, no more pollination, no more plants, no more animals, no more men. And it's a good phrase to highlight the importance of sustainable development. Okay, I finished. I'm available to any question. If you have questions, if I can, I will answer your question. And Domenico, do you have some?
Thank you. No. Thank you very, very much for this wonderful presentation. So let's open now the floor eventually to question. I hope that this session could be informative and interesting for all of you. So we have still 15 minutes. So let's use these 15 minutes for questions for anyone that wants to ask something to Luisa. So please, the floor to you, guys.
Domenico, I would give the word to you, Juan, because in this presentation could enter also your project, the project that you are suggesting.
Yeah.
I leave to you to describe it.
Yeah, but actually we are working with some colleagues to have like a smart platform for helping the climate change, helping farmers in climate change. But yeah, let's maybe develop in another webinar. So I saw Josephat that has the raised hand. Jospat actually is one of the member of the team that won the previous hackathon. So Jospat, please to you.
Domenico, I'm very sorry I got late.
No worries, please.
Actually, I just wanted to ask if you will share the presentation later, please.
Yes, sure, I will do.
Yes.
And I hope the presenter is okay if I can engage her later in case I have any question.
Yeah, so if Luisa, they asked to you if you can respond to some question later if you.
Yes.
Okay, thank you. I
Of
saw
Yeah,
Thank you.
Domenico.
Yeah, please, Dr. Dumble.
See, Domenico and the presenter right now today, wonderful presentation. First thing. Second thing, she ended with my very important topic of honeybee. And she also quoted the Einstein statement. That is also one of the important. And what I wanted to, last 2 days, I was in so much in sad position because one fellow who is, we can say it's a bad fellow, he has killed 2.5 crore honeybees by applying the pesticide. So he was this thing. The honeybees was like I am the owner of the honeybees. I have some boxes, and somebody who is a bad fellow, he has killed my all the honeybees. What he was feeling last 2 days, I was in sad position because of in India, in Maharashtra, in the incidents has happened. So that is one bad thing. What I wanted to tell you that don't kill the honeybees. Honeybees are very much important for all of us to stay on this globe. Okay, one thing. Second thing, the presentation of the smart agriculture, what she was done is really fantastic. All the new inventions she has presented there. So that was one of the beautiful presentation. Madam, can you give the presentation, Domenico, please?
Yes.
Yeah, please. Yeah,
And Anthony.
Madam, I am the master trainer for this Central Bee Research and Training Institute, which is at Pune in Maharashtra, India. I am the master trainer of them, and since 4 years, I am doing the work on the honeybees, their research and their conservation, their multiplication, and many things are there. The last point which you have, the last point which you have done was the on Varroa destructor mite. That's in India, it is not there. But in few areas like in Punjab, there are some incidences of this Varroa mite, which I have noticed. So, but in the remaining part of India, there is no Varroa destruction. Only the thing is the wax moth is the big problem for us. Wax moth. Okay, thank you very much. Domenico has given me a.
I would add in India. We have more sites in India of ST microelectronics, and in Noida there is a lab that is the same of my lab in Italy. We share a solution. So once when we will finish the work on the Smart Hive, we can pass the solution to our labs in Noida. That maybe will be more easy for them to distribute it.
Yeah. Yeah, madam, I will send my email ID to you. Please give me the details afterward.
Okay.
Thank you.
I will send the email ID. I will send the email ID in the group. You just take down it, please.
Okay, thanks.
Thank you very much. I saw Priyavrata. Priyavrata, if you want to speak.
Very good evening, everybody. So my question is that I'm working in a climate smart agriculture, but it's my concept actually. But actually, what I do in a control system in a greenhouse through the vertical gardening process. I make this project just starting now. Of course, with this project, we have some beekeeping practices also. My question is what is exactly the climate smart agriculture? What type of the innovation is there actually? So please, madam, if you explain.
I didn't understand very well the question. I asked the help of Domenico to understand. Understand,
Yeah.
Domenico,
Yeah.
hai capito bene la domanda?
Yeah. So Priyabrata is starting a project of climate smart agriculture, also starting like a you can say a greenhouse site. But also he was asking about what is climate smart agriculture. But on this, if you allow me, Luisa, there is on the call. Let me see if there is still Divine. I don't know if you want to state about the climate smart agriculture. I will give you the floor also to introduce yourself. Divine, are you there? Hello? Divine?
Yeah,
okay.
Yeah, can you hear me?
Yeah, please introduce yourself, and also if you want to explain the climate smart agriculture principle to the colleague, he was asking this point, and then we can give the floor to Luisa for the technical part, we can say.
Yeah, good afternoon, good evening. Can you hear me?
Yes.
Yeah, my name is Tokam Divine. I'm the Executive Director for Climate Smart Agriculture Network Global. I'm equally part of the founding members of GACSA. GACSA is a global alliance on climate smart agriculture. Actually, I mean, the climate smart agriculture is an approach which has triple wins. You have adaptation, mitigation, and improving productivity of the smallholder farmer. So how do we ensure that the approach actually upscales or adds value to the smallholder farmer as far as income generation is concerned? So I fully believe that it's much more of an approach, and we could equally use it could be IT for agricultural systems. You know, you could use drip irrigation. So all of that are practices that we can actually employ in the climate smart agriculture, entire system. So for me, I think those are some of the key things I can actually underscore here. Thank you very much, Luisa, for this very great presentation. I'm looking forward to collaborating with you as well. Over.
Okay. Yes. For sure, I would like it's important. I was telling that if we can create a link, I'm very happy to go on to cultivate this link between us.
May I ask a question? I'm Santosh
Sure.
Thagle from India.
Sure, please. Hi, Santosh.
Hi, Santosh here from India. I represent a company called Dhenutech Solutions Private Limited. We are working in the sector of dairy farming. We have reached like 200,000 farmers in the state of Maharashtra, which is the western state in Indian context. So we are now providing various IT-based solutions to organize this dairy sector, and probably there we are acting more like a technologist that is helping farmers, basically holder farmers, small and marginal farmers owning no more than, let's say, 1 to 10 cattle. So in here, I see that there is a lot that technology can do and bring positive social change. So if there are any interventions that you are looking forward to have using this customer base, we would be highly open to experiment and support your pilot projects and all. So I think if there is anything that you would like to do in Indian context, we would be happy to collaborate, and not just with the dairy farmers, but otherwise too. Okay. So that's just the point that I would like to make, as it is very interesting to see the phenomena which is catching up in India to use Industry 4.0 as the revolution for the agriculture. So we are looking forward for Agri 4.0 as well parallelly. And with this G20 presidency that India has got, India is now hosting this. There is a lot of movement that is happening in the agriculture sector as well, and even with the startup and research interventions that are happening on the ground. So this is just informative. So I would like Madam to comment about it. If there is any chance of this kind, we would be glad to support your intentions.
Okay. Now, I repeat again what I told before, because I think that it can be a good solution. I will speak with my homologous, my colleague in Noida, in India, and I will put in contact your association, your movement with him, so you can have a change. Also with them that are closer to you and that are more you speak the same language and some different things. Of course, we will not exit the thing, but I think that if Manoj will take the contact with you, we can have better results. Anyway, give your name, every one of you that would like to have contact for India, give the name to Domenico, and I will try to put you in contact with our colleagues in India. But again, we will work together, even if Manoj Kumar will not be able to enter, we will go on from Italy.
That sounds great, ma'am. Thank you so much for your kind support. We will keep in touch with you through Mr. Domenico. We are already in contact, and we are thankful to him too to put together this wonderful webinar today for us.
Thank you very much.
Okay. Thank you very much. We have space for one last question or interaction. So if any one of you wants to interact on to a question. So for the one that already joined, we had a webinar with Luisa. We recorded the webinar and then we will share with participants, so no worries. So if there are questions, last questions for Luisa. If any.
Hello, Domenico.
Yeah, please.
Yeah. 1 second, I will just take. I will be happy if she can make some type of intervention, not intervention, but she can do some work with me in India regarding honeybees. I will be very glad. Okay. If anything she needs or I need, we will be happy to interchange our views regarding honeybees, because they are very much important for our agriculture.
For sure.
Yeah.
Okay.
Okay. So if there are no other questions or comments or interaction with Luisa, I think that we can close this webinar. Just remember a few things. Actually, this webinar was in the cycle of the AgriHackathon series back webinar that we are following up after the AgriHackathon. Also this year, just to announce, we will have the AgriHackathon with some interesting news. There is Patrick Magige also that eventually I want to ask to take the floor. That is our colleagues from Tanzania that together we launched the project of AgriHackathon. Patrick, are you there? I don't know if you want to state a few words in closing, but before giving the floor to him, I will invite you to follow all the updates of the AgriHackathon. You will find on the Climate Social Forum website and YouTube channel that now I will share with you. And as well, all the initiative that we are running with the Global Climate Smart Agriculture Youth Network and the Virtual Academy and so on. So a lot of things are running. So Patrick, before closing, I want to give the floor also to you, if you want to state a few words. I don't know if he's on the computer. And also, I don't know also if Divine want to make some closing remarks. I don't know if they are already there. Divine, are you there? If no, okay, let's just close the call. Thank you very much, Luisa, for this wonderful session. I think that every one of us has learned and appreciate the fantastic innovation that you're running. And let's keep in touch and let's create connection for fostering this innovation.
Yes.
And thank you very much, Luisa.
Thank
And
you for you. Thank you for the opportunity. Bye bye. Ciao.
bye. Thank you. Bye.
Bye.
Ciao.